Hey guys, so today you and I are going to talk about complex code and readable code. So let's get into it. So the question in question was, Frederick, how do you balance between writing readable working code and highly complex code? It depends on the problem, and that's where complex code versus easy readable code sort of, maybe this is terminology, but let me expand on this a little bit. So there is no, in my opinion at the very least, situation where one picks between highly complex code and readable code, because they are not mutually exclusive. You are always doing you are potentially doing both, depending on who is going to do, you know, the reading of your software. So if you wrote, say, a Hello World application, and you showed that to someone who's never done any coding at all, well, that's going to be a complex code to that person because they don't understand what they're looking at. And then let's say that you, as a senior, like, experienced software developer, maybe you created your own HTTP server from scratch, and you show the code to a junior software developer who maybe just knows a little bit about, I don't know, JavaScript, or a little bit about CSS or something like that. Well, that's going to be a very complicated code to them as well. But it might not be to someone who really knows their stuff, or, like, someone who is a real senior software developer as well. And so you're like, finding the balance is really more about, as I like to say, the inherent problem, or the inherent complexity of the problem versus circumstantial complexity. And that is where people get it wrong many times, I think, and it usually happens either due to lack of skill, or well, you could probably argue that both are a lack of skill, but it's usually, I like to make a separation, because it's usually one person doesn't know how to make the thing simpler, and the other person doesn't want to, because they think that they have a better solution to the problem, which is the philosopher programmer. We can touch on both. So when I say inherent complexity of the problem, and that is the thing that makes something complex or simple, it basically means that if you have a complicated problem, and the code that you're going to write needs to fix that problem, there's no way for you to simplify that problem. As an example, if you have a long list of elements, well, if you have 1,000,000 elements in that list, then, and you're going to search for it, for example, then you can't really simplify that problem. You're gonna have to go through all of those elements. There are different search algorithms, as you probably know. It's a famous sort of computer sciencey interviewing process type of problem, right? And so when you write code for such a problem, the considerations that you have to make this a good implementation, well, it has to stand in proportion to the problem, because, as you can imagine, if you do a really silly, like, search thing on a really, really large list of things, it's going to take a long time, and your program is it's not going to work, or it's not going to be very performant. But if you, say, had a list of maybe 10 items, or like a very small list, then you can get away with writing a very simple, kind of naive solution that might be a little bit more readable to someone else, or more comprehensible, because the problem is simple. If we detach ourselves from code, my favorite analogy is, if, let's say that you have say 10 pairs of shoes, and you're going to sort them. Well, sorting 10 pairs of shoes is a pretty straightforward problem. You just pick up them and you put them in the order, if it's color or size or whatever, right? You just sort them. But if I give you a flight hanger of like 10 million shoes, that's a much bigger problem. And so that is what I call inherent complexity. Some problems are very big or very complicated, or things like that, and some problems are small and maybe very simple. And so by creating a solution, ideally what you want is that the code that you write is as readable and as good as possible, yet only as complex as needed to solve that problem. And so for a simple problem, the code is going to be small and simple. For a really, really advanced problem, it's probably going to be a complicated. It's going to be complicated to a lot of people, regardless of how you slice it, because it's a hard problem, right? The thing that you want to avoid, the thing that is really important, is that you don't want to introduce circumstantial complexity, and this is where it gets tricky. In a perfect world, as I like to make the analogy to water, or a glass of water, the goal for you when you write software is to create the best and most readable code as possible without going over any of the inherent complexity. Like, it should be a perfectly proportionate solution to the problem. So it's sort of like filling a glass of water. You want to fill it just to the top, because that is the problem, like that's the inherent complexity of the problem. So you can't actually do less than that. That is the minimum amount that you can do, but you don't want to fill it above that, because then it's going to start you're going to get water all over the table or whatever, right? This is where the circumstantial complexity comes in, and this is what happens when you're either not so good at software development or when you are a philosopher. So a person who is not so good at software development, they won't be able to sort of figure out a simple solution to the problem. So they use, based on their own understanding, the code that is necessary. And we can debate whether or not, dense code, or there are all these different philosophies about, what is good code, what is bad code. But at the very least, I want to simplify it by just saying that you're, in many cases, writing more complicated code or adding more code than is necessary, not because it's necessary, but rather because it's the only way you can sort of think about the problem. And so it's more of a competence type of thing than anything else. But then you have the other people who are philosophers, who are sort of, they might know a very simple solution to a problem, but instead of going with the simple solution, they indulge their developer gene, or like their philosophical side, and they think that there are simpler ways of solving the problem, and they sort of get blindsided, and they actually add more of that circumstantial complexity on top. Even though the glass is full, but now it's just spilling all over everywhere. It's not actually adding any value. They're just filling the cup or whatever to the point where it's no longer useful. And that is the balancing act that I think that is best for you to have with you. It's not about writing simple code or complex code. It's always about writing simple code. Always. It's just that some problems forces you to write more advanced code than in some other problems. And your goal, the balance, is to write just enough of that complicated code to solve the problem. Because now you have then the glass is perfectly filled. There's no benefit of adding more code. So what I want you to take away from this is that there is a saying between developers where less code is better, because the less code you have, the less likely you are to have bugs and things of that nature. But as I said, it's very difficult sometimes to simplify code to a problem, because it's a balancing act. If you try to be like super optimized with your solution, you might actually not you're not actually adding any value. You're actually just writing a very complicated solution to a problem that might be very simple, not because of any real reason, more than that you think that this is a more optimized solution of doing things. And so what I really am trying to say to you is that the best way to think about the balance between readable code and highly complex code is that you should simply look at it as a glass of water. Try to get it to the brim and don't go overboard with it in any way, because there's no reason to super optimize. As I was saying with the list, if you have 10 items, why would you make a super optimized solution? It's not going to make any real difference. But for a list of like a million elements, you sort of have to, because otherwise the program isn't going to really work. And that is the balancing act. Try to fill the glass and don't introduce circumstantial complexity. Try to get as close as possible to just dealing with the inherent complexity of the problem. Have a great day.